We have been looking at quadratic functions, and recently we've been focusing on both their graphs and also solving quadratic equations. A quadratic equation is where you have ax squared plus bx plus c equal to 0. We've solved it in several different ways. We've factored to solve, we've completed the square to solve, and we've graphed to solve. So let's take this equation, x squared plus 6x plus 8 equals 0. And let's solve it all three ways just to review. Factoring, what we want to do is look at factoring our quadratic equation. So we put x and x, and we look for two numbers that multiply together to give you 8, add together to give you 6. That would be plus 4 and plus 2. And then you use the zero product property where you set each of the factors equal to 0. So x would equal negative 4. And then we take x plus 2 equal to 0, and we get x equal to negative 2. Completing the square, what we do is we want to get the x squared and the x term on one side by themselves, so we leave them on the left, and then we put the negative 8 on the other side by subtracting it. And then we take this 6, the linear term coefficient, the b up here in this equation, and we want to take it and multiply it by a half, so we get 3, and then square it, and we want to add it to both sides. So half of 6 is 3, squared is 9, add it to both sides, and you then factor the x squared plus the 6x plus the 9. That becomes x plus 3, which is x plus 3 squared. That was completing the square, completed it, or make it into that pattern where it's a perfect square. Negative 8 plus 9 is equal to 1. Now when we have a perfect square equal to 1, we can use the square root property to square root both sides. So we get x plus 3. We don't have the absolute value. We just skip right to that. But then we have to remember to put a plus or minus on the other side because there's two things that square to equal 1, a positive 1 and a negative 1. Then we subtract 3 from both sides. So x equals negative 3 plus 1, which equals negative 2. And x equals negative 3 minus 1, which equals negative 4. So we get the same two answers as the other problem. Now, we could also do it by graphing. We're going to first look at the vertex. So my vertex will be x equals the opposite of b over 2a. The b is is 6, so opposite of b is negative 6. 2 times a is 2 times 1, so I get negative 3. And if I put that into my my original equation of x squared plus 6x plus 8, I get a y value at the vertex of a negative 1. So my vertex is negative 3, negative 1, which is graphed right there. And then if I plot the points that will graph here, I could look it up on my table. My parabola would look like this as I graph it. Now, these 2 points where it crosses the x-axis at x equals negative 4, and then x equals negative 2, those two are the solutions because that's where it crosses the x-axis. That's how you do it by graphing, is see where the graph crosses the x-axis. We now want to use a new way to solve quadratic equations, and this one will be helpful when the numbers don't come out quite as nicely, especially when square roots are involved in the final answer. So this is the quadratic formula we'll be using. It will be solving this quadratic equation up here at the top. This is our quadratic equation. To solve it, we use x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You need to memorize this formula. This is something that we'll be using quite a bit for quite a while, so you want to make sure you get this formula memorized. Notice here that underneath the square root, that b squared minus 4ac, that's called the discriminant. when b squared minus 4ac is equal to 0, we get what's called, I'm going to move this over a little bit, we get one double root. Basically, there's only one solution because the plus or minus will be of 0, which is the same thing. Now, if you get b squared minus 4ac less than 0, that means it's a negative number. The square root of the number gives you two complex answers. Two complex numbers are your roots. Okay? Now, the last option we have is when b squared minus 4ac is greater than 0, you get two real roots. If b squared minus 4ac is a perfect square, then you're going to get a rational answer. So it'll be rational. And if it's not a perfect square, it will be irrational. So not a perfect square will mean that your answers are irrational. You get two irrational numbers. All right, so that's the discriminant. We're going to go ahead and just use the quadratic formula to solve. So this first one, identify your a, b, and c. Your a is equal to 4. Your b is equal to 3. But I don't know my c yet because I've got to get it equal to 0. So first of all, we're going to take this and subtract 5 and make it equal to 0. So my c is going to equal negative 5. Now I can put it into the quadratic formula. X equals the opposite of the b, so it's negative 3, plus or minus the square root of b squared, which is 3 squared is 9, minus 4 times negative 5, 4ac, all over 2 times a, so it's going to be 2 times 4. So we're going to get negative 3 plus or minus square root of 9. And then I get this minus a minus is going to end up with a plus here. And then what I get from that, when I multiply those together, I get 80 when I multiply 4 times 4 times 5, all over 8. So I get negative 3 plus or minus the square root of 89 all over 8, excuse me. So that is, notice I can't get rid of the square root, so it's not a perfect square with my discriminant. This means we have two irrational roots. They're real because it's positive, but that 89 right there underneath the square root, if it's not a perfect square, that would give you two irrational roots. All right, let's try this next one. Let's identify our a. It's already equal to 0, so a is equal to 1, b is equal to 5, c is equal to 10. So if I put that into the quadratic formula, I get x equals the opposite of b is negative 5 plus or minus the square root of b squared, which is 5 squared is 25, minus 4 times 1 times 10, extend my square root over that, over 2 times 1 is just 2. So I get negative 5 plus or minus the square root of, now here I'm going to have 25 minus, notice that's 40, that's going to be a negative number underneath my square root. We get a negative number underneath the square root, that ends up being the complex roots. So 25 minus 40 is negative 15, all over 2. And how we usually write that answer then is we split it up between the real and the imaginary part. We'll take the I out, so it's going to be negative 5 over 2, plus or minus, and I'm going to have the negative square root of 15 over 2, and I'm going to have an I multiplied because of that negative underneath the square root. So this is 2 complex roots. They're actually imaginary, they're imaginary conjugate roots for that. So when we're solving these equations, we reviewed over the 3 ways we had previously done solving quadratics: factoring, completing the square, and graphing. Then we introduced the idea of the quadratic formula, which will be especially helpful when we have these square roots that don't turn out nicely. If you get 0, that turns out very nicely. That ends up being a double root. That's what the discriminant tells us. But if it doesn't work out, like in example 1 here, where you got the square root of 89, that we're going to have to leave that in that square root form, because there is no exact decimal answer for that we can write out. So we can solve quadratics using the quadratic formula every time you have a quadratic, but it's especially helpful when you have square roots that do not work out very nicely.